Okay, let's go ahead and get started. I do want to thank everybody for joining us today for our OCS-IO product launch webinar. My name is Chuck Ridgeway. I'm the Automation Technology Manager at Horner, and I'm joined by a couple of colleagues today. First of all, our product manager, Gardner. How's it going today, Casey?
It's going good. How's it going, Chuck?
It's going well for me. Thanks for asking. Also, we have our marketing guru, Marcy Tyree. How's the guru today?
I'm great, Chuck. How are you?
I'm doing good. Okay, so let's go ahead and get started. I do want to encourage you to ask questions at any time in the Q&A tab. And if you're so inclined, feel free to download the OCS-IO handout from the handout section. Let's take a look at our agenda for today. We're going to cover, of course, what is OCS-IO, since I'm sure many of you are not that familiar with it. We have previewed it a little bit here and there, especially on our YouTube channel and other places, but this is the launch webinar, so you should expect to see lots of information today. We are going to do something a little different. We're going to show you a little short 4-minute video pretty early on that kind of shows you how everything goes together. And there's just some things in the video format that it's easier to demonstrate than kind of in the normal webinar format. So just a little 4-minute video. We think it'll provide some good information for you. And then, of course, we'll take a deep dive into all the OCS-IO technical details. We'll talk about what support materials are available for the new product line. We'll talk about availability and schedule. And then at the end, we're going to answer your questions with our product manager, Gardner. All right, let's go ahead and get started. Let's answer that question. What is OCS-IO? So it's a new family of expansion and remote IO. And we kind of classify those two different categories. Expansion IO is any IO we consider that is kind of added inside the control panel. We think of that as expansion IO. And remote IO is any IO that's located away from where the CPU is located. So OCS-IO really can perform both functions, and we're excited about releasing it today. Now, OCS-IO is a new ground-up design. So we didn't design the mechanical package. We did work with another vendor on the mechanical package. However, all the electronics, all the firmware, all the software that supports the firmware, everything else is 100% Horner designed. And it was a big challenge, of course, designing a product and releasing it during first a pandemic and then a supply chain shortage. But we've managed to accomplish that, and we're here ready to show it to you today. And we feel like we've got an IO system that is fully integrated with our application software CsCApe and with our controllers, including the OCS, of course. Okay, Marcy, why don't you go ahead and play that short product video and we'll get that started. So here's OCS-IO, a new product line which represents a culmination of nearly 40 years of Horner industry experience. OCS-IO is modular. It's built upon an innovative mechanical package and contains all brand new Horner designed electronics. You build OCS-IO from the DIN rail forward. A unique backplane connector is included with every module, and you pre-assemble those before snapping them on the rail. Once those are in place, it's simply a matter of installing the base in the IO modules, using the rail as your pivot point. Let's take a closer look at the base module, which is the first component in the stack. The primary function of the base module is to provide the connection to the OCS, which is plug and play from a wiring standpoint. The first commercially available base is the CNX. It features Horner's CsCAN network, but utilizes standard patch cables for network in and network out. That means straightforward daisy chain wiring. At the top of its housing, the CNX base has plenty of LEDs to enunciate its connection status. You'll also notice LEDs dedicated to I/O status as well. That's because the CNX offers a few local I/O points of its own. The local I/O includes a new Horner innovation called flexible inputs, but more on that in a minute. As we navigate to the bottom of the housing, that's where the CNX power and I/O connections are made. The CNX accepts a wide range DC power input
so it is compatible with both 12 volt and 24 volt DC power. Now let's take a closer look at the CNX local I/O. The terminals marked 1A, B, and C are the landing points for a 16-bit universal analog input. That means thermocouple, RTD, or high-resolution 0 to 10 volt or 4 to 20 milliamp inputs. Q1 and Q2 are solid-state DC digital outputs, a robust 2 amps each. And the AQ terminal is where you would land wiring for a single analog output. Once again, 0 to 10 volts or 4 to 20 milliamps. Now for those flexible inputs, terminals I1 and I2. How are they flexible? Well, let's count the ways. When used as a digital input, you can configure them for 5 volts, 12 volts, and 24 volt levels. Or you can set custom on and off voltage thresholds. But the flexible inputs can also be used as 12-bit analog inputs, supporting 0 to 10 volts and 4 to 20 milliamp signals. How's that for flexible? Now in terms of total I/O, in any given stack you can have up to 8 modules, including the CNX base. And in the first round of modules, there's a really nice selection of digital and analog modules to choose from. We've even got an AC input module handy for retrofits and a high current relay output module for those larger loads. And of course, you're not limited to a single base. As your I/O requirements expand, OCS-I expands as well, with a total capacity of up to 16 bases full of I/O. If you ever need to replace a module in the middle of the stack, no problem. Just unlatch it from the rail and replace it.
Thanks, Marcy. Appreciate that. Hopefully you got some good information out of that video. The part I like about showing a real-time video is that we were able to show how the whole mechanical package goes together, which is difficult to do with slides. So let's start diving into the technical details of OCS-I. So in terms of where it fits in the Horner product line, let's start with that first. Basically, we've really tried to design OCS-I so that it works well with any of our product lines, whether that's an entry-level product like the Micro OCS, or whether it's our higher-end controllers like the XL Prime series, for instance. So when it comes to the Micro OCS, one of the things I think you'll see is that because we have that small amount of I/O in the base, including some specialty I/O like thermocouple and analog, in some cases, it might just be that extra signal or signals that you need to kind of complete your application, maybe just with the base module. And of course, because of the fact that you can have up to 16 bases full of modules, obviously the OCS-I does scale up rather well. So if you have a larger system, you need more I/O, you need it distributed and not all in the same control panel, for instance. Those are all scenarios where it works well. So we feel very comfortable in saying that the OCS-I works well with and will work well with pretty much all of our product lines. So we think pretty quickly the OCS-I will become our primary I/O offering. We're not in a hurry to obsolete any of our current I/O offerings, but we do think that OCS-I is quickly going to become one of our primary I/O product lines. Now, for the technical details, as we showed in the video, it all starts with the base. You've got the network connection, or the connection with the OCS is based on CsCAN. And yes, we are using RJ45 type connectors. It's a trend that we started with the Micro series and with a couple other products before the Micro series. It's something that they've been doing in Europe for a long time, actually, is using CAN on RJ45. And what it does is it makes wiring, especially inside the control panel, a lot simpler. So you can simply use modular cables instead of a special CAN cabling, for short networks inside your control panel, for instance. Also, that backplane connector is pretty interesting, pretty neat. Basically, they snap together from side to side, yet when you install and uninstall modules, you can uninstall them from the middle or really at any point by just lifting the module off the DIN rail straight out. So pretty interesting and pretty innovative backplane connector there from our mechanical package vendor. We talked about in the video, the built-in I/O in the CNX base and the flexible inputs, those two inputs that you can use for either digital or analog. And we think that's a big deal. I mean, if you have a need for more analog in your system, you could get up to 3 additional analog inputs and 1 analog output out of that base. The 2 flexible inputs are 12 bits in resolution, and the universal analog input is 16 bits in resolution. And of course, you've got your 12-bit analog output as well. And don't forget about the 2 DC outputs that are pretty robust, 2 amps each, more than our normal half amps, which are already considered fairly robust. Now let's take a look at the configuration of those flexible inputs, those 2 flexible inputs, I1 and I2 on the terminal strip. And here you can select between the voltage range you're looking for, 5, 12, or 24, or you can select a custom range and specify your own voltage thresholds as well. So once again, we feel pretty confident that there's going to be plenty of micro OCS systems that will really just need to add the base for maybe a high resolution analog input for a specialty sensor or something of that nature. Now, for larger systems, I mentioned in the video that the capacity is pretty significant. So you can have up to 8 modules in a stack. Now, that 8 does include the base. So the base plus 7 modules. Why is it that way instead of the base plus 8 modules? Well, basically because the base does have I/O built in, it does count as a module. So the base plus 7 per rack, and then up to 16 total racks. If you do the math, that's some pretty significant density there and capacity. Also, we've got 6 modules currently available in addition to the base, and we've got several more in development. We'll just briefly cover those at the end, the ones that are currently in development. Let's take a closer look at the 6 available modules at launch. The first module is a DIQ616. That is a 8-point DC input, 8-point DC output card, which is on the input side compatible with both 12-volt and 24-volt systems. It can be used in both positive or negative logic systems. On the output side, you get half amp 24-volt outputs that are positive logic in 2 groups of 4. So I imagine this will be a pretty popular module for digital I/O, as you'd expect. We've also got a mixed module that is DC in and relay out, just not quite as dense. 4 DC inputs instead of 8 and 4 relay outputs. On the output side, we support up to 3 amps maximum at 120 volts. All the relays are isolated. However, the way we've pinned the module out with duplicate terminals for both sides of the contact, it's pretty easy to distribute your commons and connect the module to the field terminal strip efficiently. So again, there's a lot of extra terminals on board, again, for the purposes of making a signal distribution simple. We've also got a dedicated 4-channel relay output card that has higher current capacity. So not only can it support more voltage, up to 240 volts AC, but it also supports up to 8 amps per point AC or 5 amps per point DC with a total not to exceed 16 amps. Obviously, because of self-heating, you don't have an unlimited amount of current capacity available. All the relays are isolated, and once again, we have duplicated all the contacts to make it easy to distribute your signals. Now, we haven't really talked about environmental ratings yet, but in general, all the modules are rated from -40 to +60, with the exception of this particular module, which is limited to +50 because of its current capacity. Now, on the AC side, this is really the first time we've offered an AC input module in years. And we just felt like with the fact that this is likely to become our primary OCS product line, and we still do get requests for AC inputs, especially for retrofits and other similar applications, we thought it just made sense for us to go ahead and support it. So this is an 8-point AC input card where you can support up to 120 volt AC voltages on 1 common. Again, we've pinned it out to make it easy to distribute your signals and connect to your field terminal strips. And there is one caveat: all your inputs, all your AC inputs do need to be on the same phase. Okay, next is a module that I think is going to be extremely popular, and that is our universal analog input module. So this is a module that has 4 inputs where each input is selectable channel for channel between voltage, current, millivolt, thermocouple, and RTD. So it can be really versatile. So if you need a couple channels of 4 to 20 milliamp, maybe a thermocouple and a millivolt signal, for instance, you can get that all accomplished with a single card. And the resolution is terrific. So it's 16-bit resolution on the voltage and the current and the millivolt. And from an A to D standpoint, or analog to digital converter standpoint, it's actually higher resolution than that for thermocouples and RTDs. But what's reported for temperature signals, of course, is in actual degrees C increments. And then on the analog output side, we have a 4-channel module as well, selectable between 4 to 20 milliamps and 0 to 10 volts. And we also include support for -10 to +10, which is still in pretty heavy use for applications involving motion, because you do end up with plenty of signals on both ends of the spectrum there. So it's nice that that's supported with a single module. Now, when it comes to connecting multiple bases together, we highlighted in the video and earlier the fact that we're using modular connectors, or RJ45 connectors. So when you're talking going from base to base, you're really, especially when you're talking inside the same cabinet, you're just talking about standard Ethernet style patch cables. It makes it really simple. If an OCS-IO base happens to be last in the network chain, then we do have a terminating plug that would plug into the empty spot there on the last base. And of course, if you're using it with the micro OCS, the micro OCS only has a single RJ45 connector for CAN, but it also does have a software option from the system menu and from Logic. You can go ahead and enable the terminating resistor that's internal on the micro OCS. But from the standpoint of the OCS-IO base, if it's last in line, you would use a terminating plug. Now, of course, not all Horner OCS products and all Horner OCS controllers use modular jacks for CAN. A lot of our products, including the new XL Prime series, use the traditional open style double plug for CAN. So it's actually quite easy to take a modular cable and to make a connection with an open connector. You really just need 3 conductors, CAN high, CAN low, and the common terminal. So just 3. But if you prefer to buy a pre-made cable from us, we do sell those as well. I believe in 3 feet and 6 feet distances or lengths. One thing you may not have been able to glean from the video, and that is the fact that the IO terminals are all removable. Okay, so they're all removable, they're all labeled, they all support anywhere from 16 to 24 AWG. They're all spring clamp style. And there's a little difference in the current capacity, but for the higher current relay module, we do use slightly larger blocks in terms of the current capacity there. Now, if you're going to use ferrules, the advantage to using ferrules, of course, is that, well, there's several advantages. One, you don't have to deal with stray strands of wire. Another is, if you use ferrules, you can go ahead and insert the conductor into the terminal plug without a tool. Of course, to remove it, you're going to need a screwdriver, but to insert the wire, you don't need a screwdriver or any other tool if you do use ferrules. And the ones that we would recommend would be ones that have a length of 10 millimeters. Those seem to work the best. Now, when you go to eject the plugs from the module, the way you do that actually is you use a medium-sized screwdriver. So you don't use a little small screwdriver like you might use to eject a wire from the terminal block, but you'd use a medium-sized flat-bladed screwdriver, insert it through the orange eject tab like shown there on the screen. And you'd also put the end of the screwdriver on the metal tab and then pull straight down on that orange eject tab. And then you'll find all the terminals will pop and eject at once. That's the trick to ejecting the terminal strips. Now, we did demonstrate the fact that you can remove modules from the middle of a base without pulling everything apart, and that's because of the way the mechanical package was designed. It was designed to support what's known as hot swapping. In other words, pulling a module out from the front while powered up. Now, when you do that, the modules on the left of the remove module will work as normal, and the modules on the right will pause until the new module is inserted. So that's how that works. And also, even though it is designed for hot swapping, when you remove a module from the front, it's not designed to pull the backplane connectors apart while powered. That's definitely not what it's been designed for. So if we take a look at some of the other specifications, you can use either 10 or 24 volt levels with the OCS-IO. The voltage range, as you can see on the screen there, is 9 to 30 volts. I mentioned previously, it's got a wide temperature range of -40 to +60 with a standard product. So that was by request of some OEMs that really were interested in a wider, at least lower temperature range than what we had offered on our other IO families. So we were able to accomplish that. Now, I have also previously mentioned that the high current relay output module is limited to 50C instead of 60C. Now, environmentally, it's designed to go inside of a control enclosure, so it's only IP20 rated or NEMA Type 1. All the CE testing is complete. All the CE ratings are complete. That's good. Really, UL should have been done a long time ago. We've been really struggling getting fast responses. Really, it's the final markings that have taken the longest. But UL is imminent. Again, whatever that means. Usually that means it could be any day now. That's what we're looking for, at least. But again, until we actually have the mark, we can't mark the products until that happens. Now, from a CsCApe configuration standpoint, you will need CsCApe 9.9 Service Pack 8 in order to configure OCS-IO, and that is currently available. So you will find 9.9 Service Pack 8 on our website. It's very similar. OCS-IO configuration is very similar to SmartRail, but there have definitely been some enhancements for sure. Now, when you go to configure your base, the CNX can support really any combination of modules. So you don't really need to worry about overpowering the IO base with your selection of modules. I know with some IO families from other manufacturers, especially, and even with our SmartRail with certain combinations, you can potentially run out of base power. So you have to be a little bit careful. With OCS-IO, it looks like we've set everything up so far, at least, where regardless of the combination of up to 7 modules that are plugged into the base, you won't have any kind of power issues at all. Now, one of the enhancements with OCS-IO versus SmartRail, for instance, as an example, is that if you're online with Cscape and your OCS, and the OCS is connected to the OCS-IO base, then you can hit an auto-populate button, and it will auto-populate all the modules that are physically connected. So that is something that you can do with the OCS-IO base. That is definitely an enhancement. Now here we'll take a quick look at some of the detailed configuration in the OCS-IO configuration in Cscape. Now you'll notice that there's something called a device UUID, and that's printed on the label. And generally it doesn't even come into play unless you have a system that has more than one base. If you have a system with more than one base, then that UUID is actually relevant at that point. And of course, we can support either the register-based configuration for traditional register-based advanced ladder, or of course, we can support the variable-based configurations that are required in both variable-based advanced ladder or in our IEC options within Cscape. Now on the right there, we're showing some of the details for the built-in IO in the base, for instance, and the fact that you can configure the inputs for the universal input, for the flexible input. So there's a variety of different settings there, obviously, for that built-in IO. And then the next thing I'll highlight is the fact that you don't have to necessarily fix the sensor types or the analog types for your configuration in Cscape. You can assign variables or registers depending on the style of logic programming you're doing, but you can assign variables, and then you can select, for instance, whether you're using an RTD type or a thermocouple type or a 4 to 20 milliamp type, etc. You can do that from the screen, for instance, by creating a screen that accesses those variables. And then you don't have to make any changes in Cscape if you want to ship machines that support different types of sensors. And that's important if you've got customers that some customers prefer RTDs, for instance, and others might prefer thermocouples, as an example. So that's an enhancement to OCS-IO as well, the dynamic configuration capability. Now, in terms of the materials that are available, basically everything is ready to go. So the OCS-IO product page, I believe Marcy put a link to the product page in the chat or the Q&A section somewhere is available there. Of course, you can just navigate to our website at www.hornerautomation.com and quickly find it from the IO section of the products, and OCS-IO is prominently displayed. So all the 2D and 3D design files are up there now. So if you're looking to potentially see how well the OCS-IO fits in your control enclosure and you want to do some 3D modeling, all those drawings are up there and available for you to download. And of course, we've got cut sheets as well as quick start guides available for you to download as well. So all those are available on the OCS-IO product page on our website. Now, in terms of when product is going to be available, so it's definitely open for orders. So your local distributor has been notified about the release of OCS-IO. They had an opportunity, our distribution partners had an opportunity to check out a webinar yesterday, and its product's been included in our latest price sheet. So you should be able to order OCS-IO starting right away, basically. Now, lead time is currently about 4 to 6 weeks, and keep in mind, we don't yet have UL. We will ship product without UL if necessary. Of course, we prefer not to if UL would get on the case here. Hopefully that'll happen soon. But again, I did want you to make sure you're aware of that. Now, from a Cscape standpoint, I've already mentioned that the version of Cscape you need is already available and ready to go. But you will need new OCS firmware for your OCS model, depending on which model you use. That may take sooner or later to occur. So if we take a look at the firmware release schedule, and this is probably the biggest limiting factor so far, besides waiting on UL a little bit in terms of getting OCS-IO out to a lot of different people. So if you're an XL series user, look out for firmware version 15.6, which is scheduled for later this month. If you're trying out the new XL Prime, which is a great new product that offers an upgraded microprocessor, all rechargeable batteries have been eliminated. We've modernized the memory structure, which is a great new product for those folks who are traditional XL series users. I would encourage you to check that out. And firmware for XL Prime to support OCS-IO will be available next month. For those of you folks using micro OCS products, we're going to be supporting OCS-IO with micro OCS, of course, but that won't happen until December. And then if you're using XLE, XLT, or the XL15 Plus, those platforms are scheduled for a new firmware in January to support the OCS-IO. Now let's take a brief look of where OCS-IO is headed in 2023. We've gone through in a fair amount of detail the modules that are available at launch, and there is the CNX base plus 6 IO modules available. We've got several more models in development that you'll see next year, including a high-speed counter module. We've got some higher density 16-point digital modules on the way, along with some higher density 8-channel analog modules on the way as well. And then we've also got a module that has a mix of digital and analog signals that might give you the mix you need for your application. So those are all modules currently under development that you will see in 2023 for sure. Now, I will mention that we do have plans to release an Ethernet base at some point, but one of the challenges with the supply chain, as I think most of you have found out by now, is that one of the chips that are the hardest to come by are Ethernet chips. And so we had to make some creative approaches with XL Prime in order to release those products with dual Ethernet modules. And we've also had to attempt to be a little bit creative and patient in releasing an Ethernet base for OCS-IO. So we don't have a definitive date yet for an Ethernet base for OCS-IO. Just know that we are hoping to have that available in the not too distant future, but don't expect it anytime in the next few months for sure. I'm going to go ahead and bring Casey Gardner in for a Q&A session. We've got a couple questions, and if you're still thinking of a question, feel free to ask it now, and we'll do our best to get those answered. All right, so we got lots of questions actually.
Yeah, good amount.
All right, here we go. Okay, so here's a question. The first question we got was, what minimum firmware is required for OCS-IO? So let's just go back a slide, and I'm sure he asked that before we gave that answer. But for the three major platforms There's your answer. 15.6 for XL, 16.2 for XL Prime, and 15.6 for Micro.
Yeah, and this kind of covers the second part of his question as well in terms of what hardware cutoff is for OCS-IO support. So the families listed here are going to be the families that have OCS-IO support. So we won't be adding in any legacy support for like QXs or some of the older systems as well. So
very good. Yeah. So if the product isn't listed on this page, then it won't be supporting OCS-IO, but it's a legacy product anyway at that point, I'm sure. Next question. Are the holes adjacent to the spring release buttons test points like on a Phoenix terminal block?
And I definitely believe so. I think they were meant to be the exact same. I'm not 100% sure, but I believe so.
Yeah, I'm pretty sure. I'm pretty confident that's what those are. Again, it's not for a large probe on your multimeter, but for a smaller probe, that's what those are designed for sure. Okay, good question from Bob. He says, are the backplane modules all identical, or are they specific to a particular type of module?
Yeah, definitely a good question. So yes, they are all identical. So the same backplane connector will come with all modules, and you don't necessarily have to have the one that shipped with that particular unit mated with the particular module. They're interchangeable in that respect.
Very good, very good. And now it is feasible in theory, but this is all theory. In theory, we could release a wider module in the future, but we have not done so yet for sure.
Yes, correct.
So it is possible in the future that you could end up with a wide module with a wide backplane connector, but that's certainly not the case at this stage for sure. Next question. What is the practical distance limit on RJ45 cable between multiple cabinets? I can take a run at this one if you'd like, but it's up to you.
Sure. Go ahead. In terms of your general experience, I know you've probably been asked this question before.
Sure. So generally, my recommendation is, if you're going to use RJ45, my recommendation typically would be to use it inside the cabinet. If you're going to be extending a network outside of your control cabinet or between multiple control cabinets, that's the point where it makes a lot of sense to use traditional CAN cabling. And then you can very easily, just in your field terminal strip or with another accessory, convert from modular over to discrete CAN cable. It's just the fact that because so many customers use our I/O inside the same cabinet that their OCS is mounted, we wanted to make sure we had the easiest possible approach for them to use in that scenario. But if you're going outside the control cabinet, generally the rule of thumb is that's the point you'd use traditional discrete CAN cabling.
Yeah, I know we did a little bit of testing regarding longer distance, like up to about 100 feet or so, with almost zero interference or a little bit of interference included, and didn't see any issues. So that was, again, we do have a little bit of testing, but again, running that lower gauge of style of cable over that distance is just much more vulnerable to interference or anything like that. So
sure. Next question. This is a question from Travis. He sees some sort of a conflict in the documentation. He has one section, he says, that claims that the bases are powered from the CAN network, and another section that mentions using the bottom 6-pin connector for power, which is correct.
The bottom connector, the 6-pin connector for power, is definitely correct. So I'll get that taken a look at. I'm sure that was probably just a section that may have been copied from SmartRail, since that was how SmartRail is recommended to wire. But for these modules, it is absolutely recommended to use the onboard 6-pin connectors for power.
So Travis, you're automatically nominated to join our documentation review team. Way to go, Travis. Good catch on that one. Next question from Charles. What end caps can be used for the DIN rail since the left-hand side has a connector protruding?
It's a good question. I don't have the exact part numbers, but we can get you part numbers for those end caps, because again, they would be part of a standard mechanical package that we use. So I'll follow up with you and get those part numbers for you.
Very good. Charles also says, do these have a Class 1 Division 2 rating? Oh, shame on me. Go ahead and answer that one, Casey.
Not quite yet, but they will be. So that, again, they are going through the final phases of testing now. We do probably expect it to be another 6 to 8 weeks or so before the rating finally gets applied. But yeah, it absolutely will be, just the units shipping right now will not.
Very good. And yeah, I don't know if in my slides, if I specifically called out Class 1 Division 2 or not. I think I may have forgotten to do that. But yeah, certainly when it does have the rating, when that rating does go on, it will absolutely be Class 1 Division 2. Next question. How do you connect? Oh, no, here we go. How do you set the node ID of any given base unit?
It's a good question, because as far as all of our other traditional CAN systems, they require it. Now, OCS-IO does not. You basically will assign a node ID within the software, but it kind of as a smart system using what it's called a UUID, which is just a unique ID for the network in itself, only used by OCS-IO. And basically what it does is, if you have a singular base, it just goes out, searches for what IDs are on the network, and then if it's a singular base, it just automatically assigns that to base 1 and is up and running. If there are multiple bases, it will report back what UUIDs it sees, and then will let you assign them to which node ID order you want based on your program. So that's if you're using multiple racks. So really there's no physical dials or anything to set a CAN ID. You would just have to be mindful in the programming side of setting different node IDs other than what you use on, if you're mixing, say like smart sticks or smart rail units that require a physical CAN ID. You would just change that in software to, which I believe Cscape kind of flags you if you have duplicate IDs for anyway.
Okay, very good. So yeah, that's interesting. This is really the first IO family we've had that's CAN based, where it doesn't have a rotary gauge of some sort to set the CAN address, and it kind of automatically does it for you for a simple system at least. How do you connect the terminating resistor to the RJ45?
Sure. So that's a good question. So in one of Chuck's slides, we have basically an accessory we'll sell separate. First and foremost, that'll be just a modular plug with a terminating resistor pre-wired. So that's on pins 1 and 2, I believe. That I think the list price is going to be $18. However, it's not preventing any customers from building their own if you have the crimping tool or modular connectors, because those terminating resistors will come with your XL and XL Prime series units. And again, you would just have those across, I believe, pins 1 and 2, and then just crimp the connection, and it's basically the same thing. So it is a 121 ohm resistor, just the same way.
There you go. Very good. Thank you for that. What is the temperature range on the analog input for PT temperature sensors?
So they are full range for both PT100 and PT1000, I believe.
PT100, I know that's like minus 200 to plus 850, but it's like you said, it's full range. Whatever full range is, it supports full range.
Yep.
That's a good question. That was from Sandor, because on our micro series OCS, which is our entry-level product, when we added RTD PT100 support to that product and did it in a economical way to avoid cost, being a problem, because that's a very cost sensitive product. But with the micro OCS, I believe it's limited to something like minus 50 to plus 200 C. So that is a product that does have limited temperature range, but that's not the case with OCS-IO that supports the full range. Here's a question from another Chuck. Obviously must be a smart guy if he's got that name. Is your stamp going to provide UL recognized or listed certification? And it is also going to carry the Canadian qualifier also?
It's another good question. It will be, I believe, a listed certification, and it will carry the Canadian qualifier. Again, we do also have a Horner Canada office that, again, we need sales to as well. So yes, it will absolutely be a full Class 1 Div 2 rating in both USA and Canada.
Yeah, and I believe something we started a few years ago, not all customers are aware of, is on our website, you do have access to, I think, the UL certifications if you're looking for a piece of paper. So those are available on our website. Good question there, Mr. Chuck. Okay, I had one more question, in case there's some others that are just getting ready to type theirs now. And that is, we had a customer ask about millivolt mode. So he noticed that on the universal analog inputs, we're supporting millivolt mode. And he wondered whether that would be appropriate for load cells or strain gauges, or whether he'd be better off with some sort of a way controller or a strain gauge amplifier. Yeah,
in that particular sense, a lot of it comes down to performance and resolution. which is, again, in most strain gauge applications, that's really everything. So in terms of high performance or high resolution, that millivolt input may not necessarily allow for those particular applications, or again, high speed applications. But again, just in terms of a standard weighing application with over a period of time or anything like that, it could be something that's definitely used.
Absolutely. You said it well. It's what it all comes down to with load cell and strain gauge applications is speed and resolution. And if you need really fast or really high resolution, then you're going to usually be better off with a specialty piece of electronics to deal with that. But if you're talking a routine weigh scale type application without super high resolution or super high speed requirements, then that millivolt input could be fine. Well, those were some excellent questions, guys and gals. I do appreciate that. And I think we're going to go ahead and wrap up our session. So again, a couple things before we finish. I do want to remind you that we do have live streams every Tuesday at 2 o'clock. Now, you may be busy Tuesday at 2 o'clock, but don't worry. They're always available for replay on our YouTube channel. And I think since we started these, we've got, goodness, I bet we're probably up to close to 100 videos we've done. So if you've got an application question or something you're trying to do with an OCS or some sort of application, or you're wanting to learn more about a particular network or something like that, do a search on our website. We've got a video search tool, and it can direct you to the video to check out. That'll get you the answers to your questions. So I definitely encourage you to check that out for sure. This upcoming Tuesday, we're actually going to be doing a live stream with content from the New Orleans WEFTech show. So WEFTech is a water quality event. Phil Horner and myself are going to be down in New Orleans. So if you want to get a little flavor of New Orleans and see what we've got new at that show, check out that particular live stream, or better yet, come see us at the show. If you're in the southern part of the United States, it's at the Convention Center in New Orleans on the 10th through the 12th, which is, I believe, Monday through Wednesday of next week. So once again, thanks everybody for joining us for this particular webinar. And again, don't hesitate to check out our videos and our YouTube channel on a regular basis for the content you're looking for with the OCS product. Everybody, take care.